Hi everyone, welcome to Cobalt Academia's Hacking Kafta video series. I'm Busra, aka RE100, an offensive security researcher and a pentest architect at Cobalt.io. With Hacking Kafta video series, we will see how to exploit vulnerabilities that we encounter every day during pentests. In this specific video, we will see how to exploit HTTP request smuggling, which is a hot topic, by using different scenarios. If you're ready, let's jump in.
In this example, I will show you how to exploit HTTP request smuggling for CL.TE. I will be using Portsivger's lab examples, which includes like 12 examples on different scenarios for HTTP request smuggling, and we're starting with the most basic one, CL.TE. I already accessed the lab, and I fired up the vulnerable website. So what I'm going to do is I'm going to intercept on and send the request again. I will send this to repeater to play around a bit. I can click intercept off again. So in this vulnerability, we should know that frontend is using content length header while backend is using transfer encoding header. Now I will explain how we are doing it. So I'm going to change the request to post request. Host is not changing. We don't need user agent, accept language, accept encoding. We can delete these, not necessary at all. Connection should be keep alive. Cookies not needed. Upgrade and secure request is not needed. So the next thing I need is content type, application, form, URL encoded. So the next thing will be content length, and then let's also write this as CL.TE, which means content length for front end, transfer encoding for backend. So we can write always typos, transfer encoding header, which will be chunked in this case. So before I specify content length, or I can write like 8, but we will see what kind of body that I will write. So transfer encoding chunked means the first chunk will be processed now. And I'm writing the chunk length as 0 so that the first request will be terminated. So the next thing I will write is the new HTTP request type, which will be new, then again post will come and they will be concatenated at new post. So let's see it in this way, like kind of 8, that looks cool. I'm sending this. So now when I send the request, it's telling me 200. When I send it again, it's going to give me unrecognized method new post. Like I said, it got the HTTP request as new and concatenated with post. It became the new header, new HTTP request for new post. So that was the solution for CL.TE, which means frontend is using content length header while backend is using transfer encoding header. In this video, I will show you how to exploit HTTP request smuggling for TE.CL, which stands for transfer encoding header is being processed by frontend server while content length header is being processed by backend server. So for this example, I will be again using Portsivger's lab on HTTP request smuggling, and I'm using the second example here, TE.CL. So I already fire up the website and I'm gonna intercept on, repeat it, send it to repeater, and intercept off again. So what I'm gonna do is I'm gonna write post request. The rest of the headers are not needed. What I need is three HTTP header: content type, content length, transfer encoding, if I can type, and yeah, then we will start another request, but it's later. So content type will be application form URL encoded. Content length will be RN and the next bytes for the content length of the next HTTP request. I will show you and fill this fill this number later. So transfer encoding will be chunked. I will write a pseudocode by some length of new request, HTTP request. Maybe it's easier to understand with the pseudocode. So I'm gonna start a new request here by saying, let's say new post, a non-existent HTTP request, and the rest should be the same here. I will just copy paste the content type and length here, and then write the message body, let's say AAA, and enter request with 0. Okay, so if you say like 15 here for the rest of it, and we need to end again with RN, this is required, like that. Okay, like that. So length of the new HTTP request, if you calculate it, it's 94, which corresponds to hexadecimal number 5D. And here the first content length will be for the RN, and 5D, which stands for 4 bytes. So this is okay. Transfer encode is chunked. I didn't do any typos. 5D is the content length, which is a hexadecimal number of here, 94. And we're sending it invalid request. I did a typo apparently. Yeah, I always do typos. Sorry, guys. Okay, I realized that I did a typo. So when I calculate the size, it's 5D. It starts with AA post. This is like junk data, doesn't matter. So it looks good. When you first send it, it gives us a 200. When you send it again, it says unrecognized post, AA post. It's just getting here and processing it. So I think it's a cool exercise. Hope you liked it. In this video, we're going to see how to exploit HTTP request smuggling for TE.CL, which stands for transfer encoding in the front end and back end. So I'm using Portswicker's lab. The third one I already fired up here, and when you go access lab, it's giving us this web page. So I'm intercepting on. I'm sending the request again, send to repeater, intercept off, and from repeater we will play around a bit. I don't need these headers. I'm deleting them. I'm changing the header from get to post. As you remember, there are 3 headers that I need: content type, content length. I always do typos. Hopefully I won't do it now. Transfer encoding. Okay. Then what we're gonna do is we're gonna write the pseudocode. Let's say there will be the length of new request. There will be the fake request that we're gonna play with. Let's say AA. We're gonna need content length, but let's first write it. No, sorry, gonna type. Let's say application x form URL encoded. Hopefully I didn't do any typos. I will need content type here. I will also need content length. Let's also leave it like that. I will have the body, and we'll write 0 to end the chunk request. So the length of new request is here. Sorry, I need to add also RN, if I can type here. It's like a requirement to exploit this. So if you calculate the length of here, it should be, I think, 93. I calculated before the video, and it's in hexadecimal 5C, it should be. So transfer encoding will be chunked, and content length should be RN plus these 2 data, this number, which is 2 bytes, and RN is also 2 bytes. It should be 4 bytes in total. So that's the request that that's supposed to work if this was a TE.CL, which means transfer encoding in front-end server, content length and the backend server. But will it work? Let's see. I'm sending it on vault request. I did a typo again. Oh yeah, I forgot the content length here. Oh, let's write 15. Yeah, when we send it, it's giving me 200. According to exploitation that we saw before, when I send it again, it should give me a post is invalid, but it's not giving me 200. That means there are like filtering happening in the background. So if you bypass WAF and web application firewall or any other filtering on web application pen testing or bug bounty, you're familiar with how to bypass these filters. So there are countless amount of methodologies that you can use, but I will just show you a couple of them. So what you can do is, let me copy and paste and write my notes here, or I can do it in here. Okay. So what I can do is when I need to play with it a bit. Maybe I can write a couple of bullshit characters, or I can maybe add a tab in front of it, or I can add a tab in front of the header, or I can say I'm gonna write it 2 times and it's gonna be like junk, doesn't matter. So these kind of filtering techniques that you need to apply. In this example, I will just say, oh, okay, 1, 2. And I will just write another transfer encoding header, and it will be just anything. It doesn't matter. When I send this, it's 200. When I send it again, it's giving me the result. Unrecognized method, AA post. So the attack is successful. It means this is processed now. It's been seen as HTTP request, the HTTP request type that I'm sending as AA post. As you can see, we started with the basic one, which was CL.TE, content length in the front end, TE, transfer encoding in the back end. Sorry. Then we continue with vice versa. And now we see TE.TE with obfuscation bypass. So as you can see, we're starting with beginner and going to more intermediate. We will see more scenarios in the next videos. In this video, we will see how to exploit HTTP request smuggling vulnerability for CL.TE using differential responses. So I'm using Port Surveyors Labs, and here, and for the example, I already fired it up, and this is the website, vulnerable website. So I'm going to intercept on, send a request, send this to repeater, intercept off again. I'm going to repeater back. So we don't need any of these HTTP headers. I'm deleting them. As you remember, there are 3 headers that we are dealing with: content type, content length, and transfer encoding. As you know, transfer encoding will be chunked, and content type will be application x form URL and coded. If I don't do typos, of course, I always do typos. So we will decide content later, or you can give something like estimate on after. I'm gonna say 0 to that, which means end the chunk. Then I will start a new request. Oh yeah, I need to modify this as post. I will start a new request by saying 404 HTTP 1.1. From there, you can write a non-existing HTTP header, doesn't matter, foo-foo. I'm sending this. So yeah, the connection is a bit slow. When we wait enough, it's giving me 200. So when I send it again, it's giving me 404, not found error. In this video, we will see how to exploit HTTP request smuggling for TE.CL using differential responses. We're going to use Port Surveyors Lab again for the 5th one. So I already fired it up. This is the vulnerable web application. I'm going to go to burp, intercept the request, refresh the page, send it to repeater, intercept off, and we're going to play around. We're deleting these. I'm going to write post again. As you know, there are like three HTTP header that we're using: content type, content length, and transfer encoding. Transfer encoding will be chunked. Content length, I will explain that later. Content type will be application x form URL encoded if I don't do typos. So from there, if you remember TE.CL exploitation, we're going to write the length of new request, if you remember. Then I will write the new request, post 404. I will explain why I'm writing this, because I'm trying to get a 404 response. From there, you're going to write the content type, the same, content length, the rest of it, let's say 5, let's say 15, doesn't matter. We're going to write AAA and 0 to end the chunk. If you calculate all these, it should be, yeah, and then RN, don't forget this. It's not working otherwise. I'm just deleting it and adding more new lines. And if you calculate it, it should be 94 or something. I'm not sure. It should be like 5D as hexadecimal. I calculated before the video, but yeah, we'll see if it's right or not. And the content length here, it should be 4 for RN, RN, and the 2 digits as bytes, for bytes, yeah. When I sent this, invalid request, I did a typo, content type. So it's 5E93 or something, yeah. When I send it for the first time, it's giving me 200. When I send it again, it's giving me a 404, not found. This is just another case, very similar to CL.TE, but it's like the vice versa, because transfer encoding is a process in the front-end server, while CL, content length, is processed in the back-end server. In this video, we will exploit HTTP request smuggling by bypassing front-end security controls. So in some of the applications, you see that vulnerability that backend accept anything, whatever frontend accepts. There is like insecure access control. To exploit this issue, we will use HTTP request smuggling vulnerability, and I'm using the sixth exercise from the Persevere lab. I already fired it up. I will go to burp, intercept on, refresh the page, send this to repeater, intercept off again. Then I will play with this request. I'm deleting this, sending request to, turning request to post. If you remember CL.TE previous exercise, let me delete this. If you remember the previous exercise, CL.TE, let's call this 2. We added content type, content length, transfer encoding, and this page 404 that doesn't exist. So what I'm going to do here, what I want to do here is that I want to write something that exists, which is the admin page if you check out the source code. So what I want to do is I want to just reach out to this page when I see, when I send a request. I'm sending the request, it's giving me 200. When I send again, it's telling me bad request. So what I want to do is I need to write the host header here, because whatever frontend accept, backend will not question it. So it's okay if I write localhost for the backend server to understand what the host is. So since I wrote this, I will also write content length and type. Let's call this 10, and let's write a body, and we'll send it. It gives me 200. When I send it again, it's giving me 200 again. That means I already reached out to admin. As you can see, now we can see admin details here. In this example, we will see how to exploit HTTP request smuggling by bypassing front-end security controls. But as we see CL.TE in the previous example, Now we will see TE.CL. So I already fired up the example and it's in here, the vulnerable application. Now I'm going to go to burp. I'm going to intercept on, refresh the page, send the request to repeater, intercept off again, go to repeater, delete these parts. Let me delete this, the solution. So if you remember, this is again TE.CL, but let's say TE.CL2 because this is a new example. If you remember the previous TE.CL, we wrote three headers: content type, content length, transfer encoding as chunked. I'm gonna just repeat these again. What I'm gonna write is, sorry, here. This is gonna be the size of the new request. And from there, I need to write a new request. Let's create it again together. Let's write this as length of the new request. I already calculated it. You can also calculate it. It's like 71, but yeah, you can just leave it like that and write it later when you calculate. So it should be post. I'm trying to reach out to admin. It's going to be HTTP 1.1. If you remember the previous example, CL.TE 2, which was also bypassing front-end security. So you need to write host as localhost, because as you remember, front-end already accept, you already bypass access control on front-end, and backend is accepting everything as front-end accepts. So host is localhost here. Then content type and length should be here. Let's say 15 because I will say like AAA. When I send it post request, it's giving me 200. When I send again, it's giving me 200. It means I already exploited it. If you see the other endpoint, like deleting a user, let's say delete a user called Carlos. And of course, we will change this according to how many more characters we added. It will be 87 when we send this. So when we send this again, it follows as a 302. So giving us the action as deleting the user. If you go there, refresh the page, it will show the solved. We solved the exercise. In this video, I will show you how to use HTTP request smuggling vulnerability to exploit reflected XSS. For this specific example, I will be using Persevere's lab, and I will be using this exercise. I already fired it up. So this is the vulnerable page. I'm going to burp, intercept on, refresh the page, send the request to repeater, intercept off again so that we can play around with it. First of all, I'm changing get request to post. I don't use any of these headers. So the next thing I will use is that writing content type, content length, and transfer encoding headers. I'm just taking it from the previous exercise that I already did before. In the previous videos, I'm just repeating it in here. So let's change the content length, make something bigger. So from there, I will write a request with an existing endpoint. As a side note, this application is already vulnerable to XSS with the user agent header. So I will be just using HTTP request smuggling to exploit the XSS here. So I continue writing this, HTTP. From there, I like to write user agent so that I can exploit XSS. From there, I will write like this, and then SVG on load alert 1. And then I will write like in content type and length as always. No space. Let's give me something small because I will just write like something not important. All right, when I wrote this, it sent me 200. I'd like to alert for alert keyword to see if it will exist here. I send it again, nothing. Send again, and it give me it in here. If I can find, yeah. So it exists in the page right now. So if I request in browser, the original session for this. It's not giving it to me. I'll request it again. Yeah, let's send this again and request in browser again. Okay, now it should work. Didn't work again. Sending this again. Yeah, you need to try a couple of times. It's not working on the first try immediately. Send it again. Original session, copy. Again, send. Yeah. So it's giving us the alert content here. In this video, I will show you how to exploit HTTP request smuggling vulnerability by using automation. We will be using burp suite, and for this specific exercise, I will be using port figures examples, and for the simplicity, I will be using the basic CL.TE vulnerability. I already fired up the lab, and this is the vulnerable application. I'm going to burp, intercept on, refresh the page, and I will send this to active scan. Let's intercept off again. So this is in active scan right now. Let's wait for the results here, or you can configure for specific vulnerabilities such as you can see the issues that can be reported, and here it should appear in here. HTTP request smuggling. You can better filter by HTTP request smuggling only if you're testing for it via the application. But let's wait for it until the results appear in our issue activity. So as you can see, an issue found as HTTP request smuggling. To see how to exploit this. So to exploit this, I will just send this to smuggle attack CL.TE. As you can see, you can keep this as default configuration, or you can you can modify the values. I'm just gonna start the attack here, and we'll see the requests. Warming up. As you can see, we saw a 404 error. If you go to previous error before 404, let's see what we get. So with the post request, we're ending the chunk here with the 0. So we're starting the new request and says hopefully 404. So we want to see 404 error message in the next one, because we need to collect it. It first needs to give us 200, and then the second request, the second response should give us 404. So it's given us 404. So this is how we become sure that HTTP request smuggling exists for this web application. So hope you enjoyed the video. I also included how to exploit it for more useful purposes in the previous videos. See you in the next videos. Cheers.
Thank you for watching my videos. Stay tuned for more content. Cheers!